Good morning. Looks like the pretzel name isn't working today. That's a shame. Do that. This is just started. Oh no, it's over here on the screen. That's right. All right, audio layers. Hey, what's letters? How's it going? All right, so we've got a basic project. I know in some of my other things. And that's right, gaming. Thank you for the host. What was it? It was donation config. There is native modules true, which we're going to need in order to actually do anything with a JSON object. And I know they hate you using that, but one of the reasons that specifically, Doug and Lake, thank you for the host, want to do this now is that they're making noises about Elm 19, which will make it somewhere between difficult and impossible for anybody else to use native modules. And I don't know if I really want to worry about source and test, since this is just going to be a toy little thing. However, this does put me in the right project to look at my other native stuff and how that works. So we'll get there in a little bit. So if we want to do this, let's call ours JSON or JSON. And then we'll have a decode in there. Json.Decode. And we'll do that for now. And the other thing I want is that in some of these projects, I don't know Elm package, if this one, I used Elm test. There's the other one that was actually kind of liking better in some of my other projects. Oh, you are not Elm projects. Euroscript, might check maybe. Antiav Elm unit. Package install. Antivanov unit. Antivanov. In fact, I do want one of those. If I could type it. All right, and then we did that with a test file. Let's see, we need HTML for that stuff. And we're going to have a test.elm somewhere. Oop. And we are going to have to import Json.Decode. Exposing, sure. What else did we need? We need a main. HTML message. Main equals run all. where all is a test, and all equals describe decoding. I don't know. I'm not really gonna have groups right away. So let's try with it decode strings. Is it equal? Hey, Ghostman Nation, how's it going? I may have to actually look at the package here. Is true. Yeah, equal. Equal. So what are we going to have here? We're going to have... Actually, I was doing this, and then the two lines. So this is going to be... doing pretty good. So if we have a JSON document... Actually, how did I do this? Or how should we do this? We need to have a JSON. So let's go ahead and reuse Json.Decode. We can't really expose everything here. Because they'll start overlapping with that stuff. So we want stringed value. Well, okay. Json.Decode.string something. And we want, then we're going to have JSON dot, well, should just be string. And does my other code give me a good sense of expected versus actual? Okay, looks like no, this is my input. So my thing I want to compare against is just this string. So we have a JSON value. We have my function, and we expect that, oh, you know what, actually, this could fail. That's the complication. Code a string. So what did they use? They used maybe a result. They used results. So we expect a result. No, it's not a result. It's just okay, right? And what would be something that was not a string? Because yeah, this is an encoding. It does not. It fails on not strings. So if we do a Json.Decode.int 42, then this should be some sort of error. And for well, no, the test suite should tell me what's going on here. And then I might want a second thing for this. Code git bash Elm reactor. Could not find modules named test. Oh, wait, did I named this? Let's have a look at this. Expectation, test, exposing test. Now, you see, I called this test.elm, so that might be confusing it. Do I have? Nope. Which I'm also going to change colors for that. Oh, hey, my, even my Explorer window managed to fix itself. Nope, wrong one. Alt. There we go. I don't know what it's on right now. Okay, so we'll have to do it this way. Oh, it's on. It counts as documents. Okay, so if you name a file, it implicitly names it the same name, I guess? And that will actually interrupt if you're trying to import something with the same name. That's an interesting... Well, maybe if you did an as something besides test, it would be okay. Anyway. Yeah, this is like a straight up syntax problem. Uh-oh. Oh, this is Json.Decode. Which might just be looking for, some actual code. So I think we're going to need to import Json.Encode to get that sort of magic value thing. And then right now all we've got is string, which I want to start out with a little bit of a different tact. I don't really understand what this decoder thing is, and I want to see if I can get back to it like from first principles. So I want to start out with an API that's more like encode, which is very clear. You do a value, or you do a thing, you get a JSON. Actually, that's encode. But in general, you put in a thing, you get out a value. So can we reverse that and say we put in a value? Now, the trick here is that this can fail. It could be an invalid. Okay, so this is just a window that is kind of in the way here. Okay, good. It could fail. And what's the order on results? Is it error value, or is it, you don't have results. Or is it value error? String A suggests that it is error message return value. So string V, is there anything I can do here that is not going to be native code? I don't think there is. So this is also where I have to reference back. Okay, this is my test reference, which I think we're done with. So we had NaCl, which we have to import. Import native.json.decode. And I think, oh, no, we have then these string equals native.json. Did I expose? Oh, I did not. I guess that makes sense. Json.decode.string. And it's going to just pass on the argument, so that kind of makes sense. Now I'm going to need some directories. So this is native module. So since we're kind of base level here, we're going to have native. We're going to have JSON. Native JSON decode.js, I believe. And then native. All right, this is where I need to actually rearrange my windows. So var user project native JSON decode equals function. And then we have some stuff, and then it returns. We're going to have a string, and this is an immediately executed function. So var string equals function of a value. So what is this actually going to look like? This is going to look like if, I forget if JavaScript needs the parentheses. Type of value equals string. Actually, I think it does. Then, we're going to have to do the fail case. And this is where I actually am going to have to hunt up some actual Elm code. And I think I've got that, annoyingly enough, I've got that excluded in my editor, because I normally don't need to look into Elm stuff. Packages, Elmlang, core, native, So JSON is definitely something. String has some number conversions. That should give us some result constructors. Elm core result okay. So I presume that there's a result error? Yeah, okay. And I'm just going to go ahead and make var okay equals Elm lang core result error. Okay. And var error equals Elm lang core result error, because I'm going to be using these things a lot. So this should be okay. Value, basically. This is a pretty simple one. Or error. Now this is going to be an object. I guess we should say expected a string. All right, and then this should also probably get over here. Let's see what we messed up. Could not find variable blah. Oh, don't I need a parenthesis? Caps lock. Which means you're probably going to need that as well. Oh, this is not full matching. Oh. All right. Do I really need to specify the error message here? is true. That case of matches error blah. Do you need a little argument precedence helper? No. Oh, we forgot the error here. Error here. Oh. And you're going to have this same problem here. So is there no output? Oh, I need to, okay, first of all, I need to return. Now, I wouldn't have expected that to actually cause, oh! Now, I don't know why that gave me blank output. Just something that will, yeah, okay, so that actually did something. I should have actually done like a dummy implementation here first, but that's something. Let's do one more basic type. We don't need to do everything to understand the principles. But we can do one more basic type just to prove the concept. And make sure we got these type signatures the right way. Decode.int. Type of value equals, oh, this is going to be a little bit more complicated. Because pretty sure that JavaScript just goes to number. So we're also going to have to say and math dot and value equals math dot round value. Maybe floor, because that just kind of chops off the. So now what we'll want is let's not expose this yet. Well, I kind of have to. I just won't call it yet. Let's just get our test set up. All right, decodes, int, okay, 42, decode int, 42, fails on not int, string high, and fails on float. No, this actually has to be, you know, something with points on it for it to work. Oops, I copied the bracket here. Result string number. No, decode int. Oh, did I get my types backwards? I need to review that. Result string A, where A is the type you're decoding. Okay, this is 24. Oh, because I have to actually convert all of these to int. Okay, so we got and then these are just two. Man, these are. Can we do? Goes debug.log maybe? Debug.log a in function log string. Oh, that's right. You have to do failed with OK 0. All right. Right, and this is just because I don't want to have to specify the full error message on these. Does the test thing have a matcher that would better do that? Equal is true is false. I'm wondering if I could do a maybe like an is error matcher that would kind of I could probably do that. Is error takes an A and oh no, it takes a result. I mean, really, it's a result anything. And it returns a expectation. I guess what I kind of want is an equal expectation. But I can't say. Well, yeah, it's just a green, so I guess it doesn't matter. But I kind of want this to see, like, expected to be error or something, instead got blah. Is error result, and then we basically have this. I can't get a proper equal out of this. Can I? Oh, type expectation, error message check. So I could just do case. Wait, test expectation. And the check to be executed. Wait. So this is a deferred execution type of thing. But this is an actual value. So error message. And check which is just a function to bool. So what would that look like? That would look like that for an argumentless function, maybe? I may actually have to do the parentheses there. So we've got result of air anything, and this is just a bool. And the error message is going to be expected error got toString result. That's what was off here. I mean, I'm not even sure I need to call the expectation, but it is a constructor. All right, so now I should be able to say is air and we'll have this on the next line for ease of reading. Is air now I probably am now going to have actually one way I can do this is just to do that again. All right, so we might in fact need the no arguments here. No, this is the 38. And I should not need this stuff anymore. Why are you mad about elm, lang, docs, syntax, functions? Syntax versus JavaScript. Functions. Function of no arguments. Elm, lambda, no arguments. Lambda with no variables. Is that a backslash? This could be an older article, I guess. But that does say function. Well, that says function too. Oh, cause that's the name. XY, N. XY, add 1. Or is it technically an I function of one argument? That seems to be the type signature. Oh, no, wait. Oh, you can do this as just 2 arguments. Custom expectation. And I'm guessing in this context, this is actually referring to a different method that's in scope. Because otherwise that doesn't make any sense. And yeah, maybe I wasn't supposed to call the constructor that way. Oh, and this is going to be... We'll test... Oh. What? Or did I just mistype it? Did I hit caps lock again? No. Okay. Oh no, because it's the expectation module. Okay. Oh, and now we lost the thing there that was giving us that. Okay, expected error got OK 0. Okay, that's a more reasonable thing. And in fact, we had this up here as well. Is error. All right, now we can get back to our actual code here. Actually, we kind of had this mostly done. I just wanted to make sure all that worked. All right, so got a baseline for int and string, which is about as far as I really care to take native types. I mean, I could do float, but it's going to be a pretty straightforward extension of int. So let's get the test going first again. Let's look at, since we're kind of going for an API that reverses this. So primitives, sure, whatever. List, array, and object would be the things that would allow you to actually construct interesting objects. So lists will make it easier to do literals for comparison in the test. Oh no, you can do, for arrays, you can do 2 lists. I think since list has to be specifically constructed as a chain of objects from the end, it might be easier to do an array. Or at least I'm assuming that the internal implementation of array is going to be closer to a JavaScript array. Let's take a look. An empty array has a table that is that. Whereas oh, that's right. I'm in Elm stuff, so I can't. So Elm is like, you told me to ignore that. Or Vim is like, you told me to ignore that. I'm ignoring it. So nil is a CTOR blah. A cons is, yeah, so arrays will be a little bit easier to do first. And then we'll have to think about how we are actually going to handle, well, object is a list string value. Of course, I think in the other Elm decode, you do that as more of a dict. Or as we might want a way to actually pick apart these things better. So right now, for composite objects, these are just going to be a lot more approachable as design problems. So I might need you. All right, it decodes, and how about an empty array? Oh, this still has to be an okay. Array, Json.Decode, array, and fails on not array. I don't know, it's supposed to be fails. Yeah, we just need to. All right, and then this is just going to be very, very mad right now because we've not defined any of these things. So we go to our basic Elm code. We add array, result string, array. That might not be a default import. Can't find type array. Yep. Import array. Types I'm generally fine with just going expose it. It's causing list A. Oh, right, I did use literal syntax for list, not for array. Which means you're going to need array as well. I don't know if you're going to have to mention types too much. We'll see. Actually, there's probably an array.empty. Package, core, array, yeah. Not that I won't need that later. All right, now where are we having trouble? Equal. Array.array A. Oh, right. Because arrays hold types. Not a function. Yep, that is in fact a true statement. All right, now this is going to be a little bit interesting. I think we can say value.constructor equals array. Now, we can't just return the value here. That's a JavaScript object, which is where maybe I was in list currently. Or maybe I closed that one. Array.js. Oh, because I actually am in Json.Decode, that's why. Okay. An empty array. So we can cheat on this right now. Is this exposed? Yes. Which is Elm lang core native array dot empty, which will pass our current tests. You know what? We should really test object. Because that is the thing that is most likely to confuse us here. Object, and this is a list of name value pairs, so empty object should look a little bit like that. Yeah. Ooh. Oh no, this is error fail. Okay, cool. Decodes an array with an element. Array dot from list. Encode array dot from list. Oh, this is where we need some argument precedence. Array.array, Json.Encode value. Array, oh, indeed, indeed. So step one is Json.Encode.int. And this, I don't think this is the final shape we wanted in, but it's a step. I probably should have checkpointed the code before this, just in case we need to start over, but remove the array stuff and we'll be fine. This is mainly going to be a native problem. Oh, you know what? This says it decodes a... This says it decodes arrays of A, but I don't know if that actually makes sense. It probably actually is arrays of... Is it values or results? Oh, no, it's going to have to be values. And then you'll have to do further decoding on them. So we need to know how to construct an array of actual elements. Get, unsafe get, set, initialize. And it's just, the table is an underlying array. So we can kind of, let's see, can I use initialize? Does this expose initialize? It exposes that initialize, which is len and f, where f is initialized there. F is a function. Now, technically, now it'd be very easy to just jam the table in there. But if this is a value coming from JavaScript, we probably want to make a copy of it to maintain our immutability. Well, that could technically mean copying down from the further fields, which gets gnarly. Well, actually, since it's just values, and the values have to be decoded, well, we should still at least copy the array. But I don't think there is a good... Oh, there's from JS array. Okay. Yep, no, this is JavaScript. Okay. And now we're getting to the point where we could be getting off into some weird experiments. We need to... Package native JSON. I'm not even going to publish this. I just want to have some local... limited... some primitives and limited array. Oh. Oh, right, because everything's new. All right. So now we want, what does it look like? It is convenient to decode children. So we want to get something that is just one. That's what we want this to look like. So this thing correctly builds up a value that is an array with something in it. So as it stands, we would have to do what? List.map int? Or no, array.map int over the result of that. Oh, because it's a result. Yeah, so that's where it gets tricky. So So it's not array.map, it's array.map inside a result. So first we have to result.map array.map int. Result string. Result array number. Oh, yeah. So this is where I might want a specific helper function. We could also see if maybe there's a thing in result that handles this. Apply a function to two results. Chain together. No. No. Yeah, we're actually going to need a little bit of a specialized map. Maybe we can actually write some non-native code here. Oh, this is going to be specific to arrays, though. Result string array value a value to a and returns a result string. Well, I mean, maybe the array should take a map function. So we're going to end up with an array map and a list map. So maybe we should make this a array of values. And I mean, for your purposes, that can be array. And then array is a function of a value, and it is going to be a result string array A, and a and the function from value to result string A. And then this will be decoder v equals, and now this will be the result.map result.map of array.map of decoder over v. Oh, no. Over array of values v. But now my test is going to have to change because all my array tests up to now, I mean, array.empty is actually fine. Not array is fine. Does not decode an object is fine. This is going to be array of values. And this is actually should go back to array. Oh, except this has to specify, yeah. I should make these array of values, because otherwise I have to specify something for the things. Does not match a type definition. Okay. Says it always returns an array A is a result. Oh, that's right. I have to do more than just that. I have to say that the entire computation fails if any of the children fail. So we propagate our failure. So we can map the decoder. But we have a result of array result. And we want to say, that's probably going to be some sort of result and then, isn't it? To result, to result, to result. Yeah, because that returns a result of the entire thing. So is that result dot and then? We have to do the array map. And then is going to take only continue with the callback if things are chained together. It is helpful to see its definition. Okay, so and then. If it's a value, we call the callback with the underlying thing. Whereas map, but map wraps it back in an okay. This can explicitly change that. All right, so and then only applies the array map if it is successful. But we then have to do something to the result of this array map. Does this turn to a function composition? Something like that. Do that just to be sure. Well, no, I know the other composition operators help you keep that separate. And then we have to do an iteration over array where we take well, if it's an error fold, it might be the right thing. All right, I'm going to take a short break and be back in a minute or two. Alright, let's cut it right at a song break. Alright, so that's on, that's off, that's off. Cool. So we go to a decoder. So the weird thing is that we need to return either the complete array or an error. So I could do that as a fold that returned either the array plus the latest step or an error. Well, I do have to actually convert it from an array of results to an array, so I'm going to have to reconstruct it regardless. Yeah, we would need like a filter map. I think we have that on list, but not on here. Now, push an element onto the end of an array. Yeah, so the easiest way is going to be to add things to the end. So is that fold left or fold right? All right, so list builds back to front. So this suggests that fold left gets 1, 2, 3. Array dot fold L. And this needs a function. It needs an initial value. Oh, this has the value is a result because this is an and then. So our initial value is that. And then that gets applied to the array of stuff there. Array.foldo. All right, and then we need a function in here, which is actually going to be quite interesting. Which takes, so this is an array, A and B. It's an array A and returns B. We happen to be returning an array of a different type. Oh, no, the fold. Yeah. Actual B. So the fold L takes the element, the result, and we do, now this is a multi-level case. Case res of, can we do this with a result map of some sort? This is kind of an and then, because once we get to an error state, we're going to be in an error state. Res result dot and then now it's not just a straight and then of L, which is a result. Array case L of, yeah, because we have to append in the case that it is a successful result. Was there like a map 2 in result? Apply a function to two results if both are okay. If not, the first argument, which is an error, will propagate through. Okay. Result.map2. And the function is let's map 2. So it's saying plus, which doesn't care about order. But I need to do array.push, basically, which is A array A. That is actually the right order, I think. That could be interesting. Array of values. And then this thing, which maybe we should get some names for these, but we'll have to see if that makes sense. And now we get the little type maze. The result error B. Right map decoder. All right, maybe we need to pull some of these things out and kind of figure it out. Let's do we're gonna say X is a, and then it's gonna yell at me. Let's just see what that signature is. It's not even complaining about that. Okay, here we go. Okay, the total of that is a result X array A array of array result XA, result in X array A. It's not unreasonable. The thing we want out of this is that we map the array of values to an array of results, which would be that thing should only be taking one argument. No, because we're doing a function composition that gives us the result. Oh, do we have to flip arguments on this? Well, no, because we're going to apply one argument to it when we compose, right? Or maybe this should actually be here. Still got a bunch of type errors. Okay. Because then this thing needs to be a complete call, I think. Oh, maybe my parentheses are wrong. Oh, yeah, my parentheses got all messed up. Because you're part of the foldle, and then you're there. So this thing, where'd my X go? Okay. And it doesn't know what the result is because we haven't passed the value to it. Okay. Oh, that's on 18? Second argument to be result error array A, but the result is, oh. That's going to be one of the things messing us up. Okay, now we've got an actual result. An array of result errors to a result error. A. Okay, so that little fragment is what we expect it to be. And then this we switched. We were just trying to debug stuff. Oh. Okay. So that's a reasonable array implementation. Takes a converter for the children and spits it out. Okay. Nope, wrong one. That's just you. So array of values will probably end up not being an exposed thing. It was just really convenient for the test suite to be able to sort of work up to that. Oh, you know what? Well, you could do array with a no-op to get the values out. But you have to do a lot of stuff to get array to work. Okay. Oh, decodes in the correct order. It maintains array order. What? Oh no, that's the. Oh, okay. Array.fromList. Let's try to do list.map Json.Encode.int 1, 2, 3. Okay, cool. Usable array. All right, so Json.Decode. All right, so now lists are we're going to actually use most of the time. But now that we know how to do that, we still kind of need to do some debugging on list of values. And then the actual list operator. Well, no, we might be able to skip to that. So it's going to look more like this. It's going to look a little bit like this. You know what? These are actually getting big enough. In some cases. Well, how about we just do primitives? Save. And then we do describe ints. Describe arrays. Because this is getting a little bit longer and more involved here. Ah. So we misbalanced our... Oh, indeed. Yeah. Our brackets. There we go. So now we can do lists. empty list. This we've got little literal syntax for. And we're going to try to switch back straight back to this. And I am like not even worried about this because the underlying type is the same. Code's a list, an element. We're actually just going to skip that. Code's a list with an element. And this is going to be a list. List. Don't need that. Maintains list order. Don't need that. List. List. Don't need that. Really shouldn't need that. Cannot find variable list. Decode. List A, decoder V equals. Okay, list. $56. Oh, we missed an array from list. Oh, yep, indeed. Okay, there we go. That gives us our basic stuff. So now we're going to need a list of values. Actually, you know what? You know what? Well, I can't directly test it if it's not. It's not a thing. Anyway, so we expect this to look pretty similar to this. So that could just be the native call. You know what? My test package could totally just import that and test it, couldn't it? I don't necessarily want to expose all that of values of Json.Decode.array. Then I can do the same thing down here, and other than losing a type signature there, that does cost me a type signature of a native method, effectively. So Elm would not necessarily know what it expects. That might, maybe we keep that internally. Oh, not Json dot. And eventually that would not be an exposed thing. And I was also starting to work on list, which we don't have a native method for. So it's going to be list.map, list dot there. This cannot be. Oh, this goes on the end, so we're going to want to do a fold right. List, which is going to just be that. Oh. I mean, that makes sense. We've got syntax for it. And native does not exist. Not surprising. Now, we may actually have to do some finagling here, because it's, well, maybe there's a helper method for list that does the same thing. Can I even... Nope, that window's dead. Okay, did I open list already? Open string. r.length, r.I. Out.push. So these appear to be two JavaScript arrays. So we should be able to do native list, expected list. Oh, and we have to actually publish it. Status. Commit decode list. So what I'm starting to feel like right now is that decoder is just an alias for value result string A. And I think that would kind of map to most of the API. Decoder string, decoder int. So we'll finish up object, we'll pretty much finish up our reverse of, although decoders do get a little bit more complicated in terms of, oh, yeah, you know what, I'm gonna have to get into maps to do objects properly. Because the straight up inverse of the encoder API is a list, which is effectively a dict. So main. I might, yeah, you know, this probably might have to be like a name value list of elements. I don't know. Oh, we did have field. So maybe I should actually do a little bit more start. Well, let's do our empty. Decodes an empty object. Wait, what's an object? It's usually a constructor of something. In the existing API. So a straight up inverse of Json.Decode would be a list of string value. Which would be more of a JSON.Dict, I guess. So the decoder API, is it object? Object primitives, field at index, JSON array requiring a particular index. We've got maybe one of mapping. Oh, succeed and fail. Those are pretty trivial. Things you'd need for a more realistic implementation. So the typical... So yeah, actually objects are done with map. Go to JSON object into an Elm dict. To an Elm list of pairs. Key value pairs. Oh, key value pairs as the public method takes a decoder. I think native object is going to have to. Something like field might actually be useful here. Decoding an empty object doesn't make any sense. Let's try something like key value pairs to start with. What is that going to be? That's going to be a list. Key value pairs int. Json.Decode.object empty. And I messed up my parentheses or something. Oh, I have to close this. JSON. Key value pairs is a value to result string list. Oh, no. Key value pairs takes a value result string a. I guess for custom decoding purposes, maybe the sort of raw. Yep, I bumped the key I had mapped to mute. Okay. And that's why alarms are good. Is object of values could be used by key value pairs. And actually we could even once again do native, because I don't know if I'm really gonna need that. Native.Json.Decode that object essentially. And then that fails there because we don't have native. All right. Object. And value constructor not equal to array, I guess. All right, now we're going to have to do something a little bit more complicated here. So we'll do list from array, but we'll have to build up the array ourselves. There's has own property. Yeah, no, it's just var key in value var fields var key in value should this be has own property or should I get it carry down fields? Base methods are already set in unenumerable, so fields dot push oh, these have to be Elm tuples. So do we have a tuple library? Basics. Native utils tuple 2. Let's grab that one. So that's gonna be their pretty common thing. Well, maybe it's not gonna be that common. Expected object. And maybe I'll have to do something more with that at some point. And then object, which I think is what I was calling directly. Okay. Main. And then when I got to decode an object with an element, this is a Json.Encode.int1. Decode.object. Expected OK1 instead encountered function toString. Nope. Expected object function toString native code. Oh. ToString enumerated? No. Oh. Oh. This has to be... Give it the right data. All right, and then we can have a object of values to type that. Native.json.decode.object. All right, your equals. All right, so that is a untyped object decoder. All right, now we need an actual thing that decodes. So now we want to do key value pairs equivalent. That's sort of the next step. You do an object with one decoder. Or one decoder. Decodes a untyped. All right, so now we want, instead of this, we want object with an int And there, which doesn't exist yet. Oh, no, not object yet, just key value pairs, which is effectively what this is. Main. Oh, which is actually, yeah, array. But it's a typed array. Key value pairs takes a value to a, actually, it looks exactly like this. Except, oh, no, not exactly. It is, because now we've got a type, which is a function of value to a. And this is a key value pairs equals, probably going to look a little bit like our list decoder, maybe? We take object of values. That can be a list.map, but it's not just this. We actually want to decode the pieces. Ooh. So we did object of values. So I need to translate the tuple string value into a, well, in order to apply my fold trick, Oh yeah, because it's key val to decoder val to a result dot and this is more of a map. I think we still want that parenthesis there. But don't I have? I pre-closed this one somewhere. What? Yeah, okay, so that, no, yeah. Okay, so one of those is bugged. I don't suppose. There's a handy little function to apply something to the second part of a... Well, the result is a bit special in this case. Yeah. Because we want a result of that so I can continue to do my little folder trick here. And this will be no doubt totally messed up. Oh, no. This is supposed to combine things without having to do a bunch of parentheses, right? Oh, no, decoder val. Should be a result. You expected the right side to be A to B. Oh, because there's different result types. I don't know. Seemed good to me, but it's unhappy because the result.map takes a result A to a result BA. Oh, maybe this has to be here? No, that seems even worse. I want to take a tuple, break it up, run a decoder to get a result of whatever. Oh, and okay, that was the previous version, which had that type. Helps if you save. I don't have a type annotation there, you jerk. List.map. Subject to values is a list of things, actual things. We and then that to get to the list. The list goes into the tuples. We decode the value. Well, you know what? Let's just take this out for now. Everything will be broken, but it will give us a better error message. Yeah, that used to just be decoder. Why? the right side to be list AC. List A to C. The right side is a list result error A to result list error B. Yes, that would be correct. What the heck? Blah, blah, blah. Well, that depends on their list.folder is expecting a list A to C. Is a list result error. What? Does something here not work with tuples? Well, I'm not necessarily matching my type annotation right now. All right, so let's fudge this and say x is something that will give us an error. X is, we had x key val equals, yep, tuple. That's what I was thinking, comma. Oh, we'll just give it a constant thing because it's eventually going to be that. Int val apply that to, what was it? Result.map typed to what do you think that is? An A to val to a result string, A to int. So we think that this should be a string to value we don't have a decoder right now. And it should give us a result string int currently. Oh, result, right. Okay, so that's fine. Now, if we made this take an actual decoder, and the argument order would be, we're putting this through a map, so it would be value to result string A. Result string, string int. Oh. Okay, we're back to this. Now I've got a fully typed thing here. The only problem is Value result string A, but is a value A. Oh. Ah. Okay, now I've got parentheses messed up somewhere or something. Or did I? Yep. All right, now. All right, so that was. We either need to find a name for that. Or we can just switch it to inline. Like it used to be. And that's where it was. Okay, that one matches that. The bounce back doesn't for some reason. Decode's a simple empty object. And that was doing. Yeah, okay. Decode's a simple object with one element. And that's going to be a 1, 1. Did I already create? Yeah. Object int. No. Key value pairs int. Actually, you've got parentheses. I don't think I need more of that. Okay. We've got key value pairs. All right, so using Json.Decode for this is starting to get a little bit awkward, but oh well. All right, so now we have the is convenient test. Can we do Also, I think I'm far enough into this. This wouldn't be a native thing. This would be Json.Decode. What is the type of decoder? Oh, they've gone full primitive on this for performance, probably. Yeah, everything is just native. So it kind of doesn't matter what a decoder is. Because they just pass it on down. So I'm going to guess. Well, you could probably figure it out by reading the implementation. You know, what do the functions do? I'm going to guess. We could do type alias decoder A equals value result string A. And then we could do this as decoder string, decoder int. Now, in Elm proper, it's not a type alias, which means you can't actually define some arbitrary decoder function. So like, I mean, like things like this, I'm kind of building on top of other things and then doing more stuff to it. I'm not sure you can do that. Well, you can't take in values. You can call base decoder methods. You just have to call the sort of meta wrapper things. Decoder. This is a decoder A. Wait, what is array then? Okay, yeah, so it returns a thing which is actually a function. So now the way this takes a value is not reflective of the function signature, I guess is the thing that's weird now. So the other thing is that unlike the encoder library, which has very plain readable signatures, doing this conversion, while it works, hides that plainness of signature, although it does make it easier to type. Well, I guess it makes the function of array a little bit. You know, I could probably... Here's another interesting little experiment. Could I do that and take you off? Yup. So now it starts to look that's more like a type. So that, yeah, man, I don't know. That gets us back to what Json.Decode is. But then it leaves you, well, I mean, so other than the fact that we've got a straight up definition here, kind of leads you back at the same place, where it is not obvious what is going on. So maybe this is the thing you would use for user code. And this, well, but if users are using it, then having that be the type of thing you would actually use. You know what? I probably don't need that anymore because of the priority of the arrows. Now, did I do that anywhere in here? Okay. This decoder A equals value to result string A. And hope there's no special characters in there for getter shell or something. All right, let's see if that hopefully doesn't confuse me too much. All right, objects. All right, so we got simple object key value pairs. Now, we know from the base library that a lot of times what you want to do is to decode some sort of structure. So with the well, yeah, because you always get a result. So let's avoid the, well, we might want to have like map. Let's start thinking about what it would take to build up a constructor example. It is convenient to use with constructors. So, what's a trivial constructor we can use? I mean, just another result. That's a trivial constructor in the base library. So what is that going to look like? It's going to have a field with a 1. In the base library, it looks like map OK onto field 1 int, and I should check. It's string decoder. Okay. Oh, so that means we need both fields and decoders. Which means we have to mothball this for a little bit. You know what? This is not even object. Well, it kind of is. But we need both map and field. Well, map is applying the constructor to it. So this should just be OK1. We lose that. Field 1 int value. Pick out one field. Yep. Json.Decode. So I can do this in straight Elm. Maybe it would be more convenient to, well, I'd have to deal with a function then. So the straight Elm definition is field string decoder A decoder A? Field key decoder equals. Yeah, and this use of decoder is already kind of obscuring the use a little bit. Anyway. So the simplest thing we have right now is object of values. And then we want to do something with that if it succeeds. Is this be more of a map situation than an and then situation? We could not find that field. All right, I'm going to take a short break. And then I'll... Yeah, because it would be a failure of that if it did not find it. All right, welcome back. We're in the middle of that. Get that visible. So we were saying what? That we would need to do an and then rather than a map because we could fail on field not found. And then we need something like... All right, I think we're done with you. That's E unit. End up double core. So we've got a list of name value things. For easy searching, we'd actually want to convert it to a dict. Filter. Filter map. That seems like it might be an interesting kind of fold. Determine if any. Where it says, if we find a field with the matching name. Oh wait, object of values. Oh, I actually have to do... Oh no, actually I need to do key value pairs decoder. Which actually sort of means I don't have to even specify that. No, because that's going to try and decode every single field with that decoder. So it's going to look more like this. Somewhat more like that. Maybe. And then we need to... We might immediately, like, do the folder of sorts. Well, no, it's not even going to be a list. Yeah, this is a fold of some sort. This the object of values is key value pair key pairs. Folder foldel. I don't know which is going to be more efficient for a list. Fold L, I think. And then for each entry, we say if, oh. Well, you don't matter. If key equals k, then yes, I did. The keyboard's sitting right under the desk here. Then the result is decoder V. Else it is error key not found. Now this is actually this is a function of two things. Fold, this is in fact list. So we get a B. So it's A and B. So this is our previous result. So that takes care of so we could map all of this to results. Does result have any easy method to take the one thing that succeeded? Not easily. Filter. Oh, filter map. It's a maybe. But then we would turn around and map the maybe to a result. From maybe takes the X. Okay. So I could pass fold L. No, map 2 propagates errors, I bet. If both are okay. Yeah. List dot filter map. I mean, it's kind of a fold. But it's like, as soon as we find one that succeeds, we don't have, well, you'd have to do a case on the result then. Oh, so I wonder if that's like a map to or an and then. No, because the result tends to keep a failure as soon as it's a failure. I need to go through a bunch of failures and maybe have a success. Oh, but decoder returns a result, so I have to map it to I have to check its result, convert it to a maybe. Oh, and if it fails, we won't get decoder failed, we'll get field not found. So if we find it, we really want the error for that entry. Oh, so maybe it is then just that, else nothing. Result dot from maybe. It doesn't have to be an error, it just has to be the actual value. That's a, oh, we want exactly 1. Reduce a list. Okay, that keeps only the matching thing, which is probably 1. In an object, it really should be 1. And this might be something where it would be nice to use a native method. At least to fetch the field. Because that would kind of make things a lot easier. So a filter map could possibly empty list. Well, we could just do a filter map and then run that to a case. Or the fold has to manually handle the previous case. So fold L, A, B, A, list A to B. And now it doesn't have to be a maybe. But now, case res of, okay. We haven't found it yet. Keep searching. Oh. Now I know what we do is we do else res. And then we do the default value is field not found. But otherwise, we will take the error and keep on propagating it through. That's not surprising. And then it was given 4. Okay, so this is just a precedence problem. That was probably there for a reason to begin with. It is string result string. Second argument, result string A, but it is string result string A. But its third argument to be list string value, but it is string. Oh. All right, so now we need to check. It picks out one field. It now this time we actually care about the error. Reports downstream decoder errors. And this is going to be error. Not an int. And then we're going to make this. And we're going to do, no, let's go back to this-ish. Error, field not found. We're looking for 1, and it was actually 2. Expected an int function toString. Okay, well that's, field not found, found 1. Okay, so we need better error messages. Now, expecting an int function toString. What? Json.Decode.int. Parts downstream decoder errors. So this should be, then this becomes an error if it finds the key and that doesn't work. Decoder V. Parts downstream errors. It's 1. It's a string foo. We tried to do an int on it. Function toString. Does Json.Encode not do what I think? Oh, no, I didn't pass the argument. Possibly in native. Oh, yep, I didn't call the actual function because I'm used to the Elm, which lets you do that without arguments. And I haven't really been checking error messages. Okay, and that's just my error message is wrong. Also, int, on int. Picks out one field. Oh. Reports, field not found. All right, so that is a pick a field out of object. Now that could probably be a heck of a lot faster versus iterating over the entire list. What would native look like? We'd first have to do similar things here. Okay, well, yeah, I mean, expecting an object is a valid thing here. Then we get into the second level if... Because this is going to have to be value... I think key value is fine for the native layer. And then we can run the decoder on it at Elm level. Because it would probably come through as a function, but I don't know. If value key, well, no, you can actually, if key in value, I believe is a thing you can do. Else return field not found. Let's see, so we've got this in source control. So this would look like native.json.decode field key. So now we've got to do this because our intermediate thing is the one that's missing. And then we do a result.map decoder. Now I don't, that doesn't allow me to do a type signature for, how about field value is a string value decoder value? native.json.decoder.field. And that will tell me if I'm at least thinking right about this or if it's a native problem. Does not match its type annotation. Always return to decoder A is a value string result A. Oh, you need arguments. Key V. Oh, you are not missing arguments, so you actually execute right away. To be a decoder value A. The result string value. So ours field value actually a decoder. No, it does return, it takes value is implicit in that. Let's see, value result string A. Oh, you might be an and then. Wait. Native.json.decode. Oh. Cannot read property arity of an if we have two argument things, oh, well, first of all, field, we have to specify that it is a two argument function. Fields. Oh, I left this in here. And this is not list from array, this is just an OK. If key in value, then value subkey. Field not found. Probably should do that. There we go. Oh, and okay, we've been going 3 hours. Cool. So that was just, it was fewer native methods, but that was a lot of work. Actually, what was, there was field and there was at. Oh, field is the, at is the multi-step version of field. That could be probably be done in Elm fine. Index could probably be done in Elm, could be done more efficiently in JavaScript, but field in JavaScript. Well, the core of it anyway. All right. Okay, primitives, fine. We don't handle nullable. At and index, I mean, aren't terribly interesting now. Maybe one of is just handling results. And actually, my old implementation of field could have effectively been a kind of one of. Oh, that's the thing we need to do. We actually need to have some sort of map to handle convenient objects. So given something that picks out a field, we want to say we have a convenient with constructors, and we'll just go ahead and use OK again, or maybe just to simplify things. Let's do that, and so yeah, so the way they did that was map, which actually ought to be pretty straightforward. Nope, wrong. Something unexpected. Ah, there we go. Gotta find variable map. All right, map takes a by itself, it takes a function of is it just an A to B? And a decoder A and the current decoder B, is that right? Wait, so is succeed is a, well, it's an A to a decoder, but a decoder is a function which takes a value and returns. Map F decoder equals. All right, so decoder fine. There's an implicit, we can work it out to have that implicit, but there is a value there. We apply the decoder to the value, which could be that without naming it. And then we do result dot and then, is it and then? No, this is a result dot map, F. Decoder int results string int. Is that the right type signature? Because we can cheat a little bit on that. They give it different names, but yeah. I expect the right side to be a decoder int. Do I need to actually change main here? Because it's kind of a pipeline going that way? No. Oh, yes. Because map is actually getting the value here. Okay. So yeah, that was returning a result. And then like map2 is Yes. We'll do map2 just for proof of concept. And I guess we should actually have two fields. But you can't use just for that. How about list? So we can use that. No, that doesn't construct. I think tuple. We could use tuple constructor. Let's do string just to mix things up. And my lines are really getting out of hand here. Object 1, 2, Json.Decode.string. Couldn't find variable. Okay, so no other major syntax errors. This is an A to B to... Okay, and this is why we've got out here. So you can just kind of keep on adding these A to B. Well, actually, the way decoder, the final decoder is a little bit different. It does kind of map. A, B. Oh no, it's so you're actually A, B. And then it's just a question of what is your order? Oh, wait, result.map. Oh, no, because that's the decoder. No, F. Yeah, F. And we have decoder A and B. No, decoder A. So now we have A and B and a function to combine them. But how do I set this up so that you get the argument? Probably have to explicitly specify it as the easiest thing to do. And then that extends as result.map2, assuming there is a result.map2. Oh, map W. Oh my gosh, LMY. Oh, you can't do... mixed lists because they're typed. All right. The different types is not an essential feature here. I'll still get ordering out of the 1 and the 2. Result string, list number, result string. Oh, because I can, yeah, syntax. Wait, why isn't int number int string? Oh, because this is still specifying int. All right, so that's a proof of concept. These do not extend nicely. The way you extend it nicely is it is convenient with pipeline. We'll start with that, which is succeed. Do I need succeed? I mean, it's kind of just v return okay. Oh, succeed that. Now I'm uncertain which operator it is. And then we were mapping things onto it, right? Oh no, it might have been and thens. Oh, yeah, that's their hook for that. They don't handle nulls. That should be straightforward. Yeah, so succeed and failed, and then. There was actually a little bit of stuff you had to do that style. Let me get an example. I think something in the Twitch stuff. None of which is brought up right now. So the most recent was schedule. Got into that style. Okay, so it's a map 2 of this operator. Yeah, okay, so yeah, there is some some funny stuff there. Oh, and it does take map 2, though. Of field. And I needed to make sure that this entire assemblage that gets applied to here, I think. This is without actually defining succeed for full parity, but... Oh, this has to be a, okay. Oh, and okay. And then we could, for full parity with our old one, do succeed is a decoder A. Succeed equals an A no, because we have to throw away a value. I think I got my brackets wrong somewhere. Oh, yeah. Probably this one? Yep. And then we could do Json. Did fail always fail with a message? Fail string, yeah. Fail error v equals error. And as long as that doesn't cause a type error. Oh. And then, you know, it's something that we actually used on occasion in realistic decoders. Mapping. So let's do a test. Now we're kind of shoving stuff into objects here. This is getting a little bit more generic. This is kind of like map. It's going to be a little bit different. So this is going to be OK 2. Let's do something a little bit more interesting. Let's do OK 6. Let's do 3. And no, this is not the same. Hmm. Hmm. The result of the decoder we run. That's the typical example. Well, what it has to do is return a decoder. It doesn't have to, for basic testing. So we have to decode a value based on a decoder a function that returns a decoder. Have I used this in practice anywhere? Timestamp. Oh, I used it to explicit succeed and fails. And the succeed and fail are just things that... I did do it in their conversion there. So we could actually say... Okay, how about this? How about we say... But this is fail E. So that field 1 string so it should be we should actually get an error. And then end is not defined. It's probably actually make more sense down here. And then A to decoder B, decoder, and then has a very peculiar signature, so I don't think I can just wing that. Or and the way and then is used in Elm, it is used in very specific ways. So map was an F. And a decoder. And maybe a V, depending on how we do this. So what does this do? Depend on previous results. So is this a decoder result.end then F instead of a result.map? Which makes me feel like we're just kind of writing result wrappers, but it is a decoder. Okay. Not quite. Maybe-ish. So we decode A, run it to and then. Result is complaining that it's expecting an A to result string B, but it is an A to decoder B. So is this actually no, but it is A to decoder B, and then is expecting that. No, because that's to a decoder. It depends on previous results. So we pull out the field from the value, and then apply that to the same thing. So we do have a sense where we're reusing V here, or our value. And then so the thing we're passing is a to value to result string B. And actually, we kind of don't need that. And our applied decoder is a result string A. I'm going to need a break before I figure this out. One moment. All right, and I think we cut that right between songs. All right, that's good, that's good. Oh, so it wants a function that is only one step along here. So result.end then wants that. Helpful to see its definition. Okay, so maybe what we need to do is actually just implement this. Case decoder V of, there probably is a way to map this through. Of, okay. A. Apply F to A to get a new decoder. And air is just O. Oh, result.end then expects a result out, though. So I have to maintain that I'm returning a decoder. And that doesn't run anything. Now, wait a minute. That should have worked, right? But except the types. The implementation, it would be fine. But the type is wrong. Because this returns a decoder, which actually is this. And it expects just that. Oh, maybe not. Oh. Yep. Similarly, no. And then says it always returns a decoder B, which is a value decoder B. Ow. Oh. Well, in this case, this could be error. Aha. Yeah, because then this gets applied to the same thing. And I was just using a cheesy switch it to an error to prove that we ran that function. Or just to an error that used the result of the computation to prove that we were actually returning a full decoder different result. All right. So there are a couple of other things. Oh, you know what? The way we could test, well, yeah. It's still nice to test the underlying implementation, although you probably wouldn't normally expose some of the things. So you got noble, you got maybe, you got a couple of those things. Okay, so this was my native helper. String library, array, list, basics. Looks like I lost the thing where I was doing. No, documents. Elm stuff, packages, Elmlang, core. Well, there's two pieces here. There's the wrapper and decode, which they seem to have heavily minimized for performance reasons, I'm guessing. Yeah, decode field. The map there is nice. Decode container. I guess, yeah, maybe it could kind of be a container thing. Native all the way up to map 8. And even native JSON succeed. Lazy thunk. All right. And all the JSON stuff is actually stuffed into one. Oh, decoders actually are custom things. Huh. Decode container. Tag. Decode primitive. Well, they're doing some custom field stuff here. And then decoder callback. Map 1, yes, use a map many. Code helpers. Okay, index. Bad field. Nested problems. Bad. Okay, so they do a fancier reporting. JS to string. Run on string. Yeah, I never actually did that Json.Decode step, but it's kind of, it would be an easy thing to do. Run help. Oh, so they've got like a whole like interpreter thing in here. I mean, I guess for the primitives, it makes short work of it. There's int. So it's checking for number. Finite. Oh, yeah, this is probably a better way to check for leftovers. It's interesting that they're putting their different bounds on it. Oh. Oh, they're also checking for instance of string. And they're doing more of this stuff in JavaScript, once again, probably for performance reasons. The maybe is in here. passing the decoder, the subdecoder directly in and running it in JavaScript. Whole thing for key value. Oh man, even this stuff is implemented in JavaScript. And then there's all the encoding stuff, which is much simpler. In fact, a lot of it might be an Elm. Anyway. So that is, so I mean, a lot of this comes down to Json. To this, which I went ahead and implemented. Also, we don't have that huge error message anymore. So I can relax that a little bit. That while they like hiding implementation details, and in fact, I'd have to troll through the Elmlang repository to see if that definition ever existed in earlier versions of Elm. But they made it a type, not a type alias, and forced so people could only use decoder A. And then they made it an internal type. But you can have a certain intuition that it's a value result string A. I don't know if you can ever use that, really, because it is now an internal type. But I can at least sort of understand it now at a level equivalent to... You know what? There was a thread a while ago. Could have designed Json.Decode. Big stumbling block. Oh, they're actually going from scratch and not having real JSON value. Yeah, I mean, I guess this lets you sort of deal with it at a pure Elm level, having to go to the native tricks. Read operations, JSON value. So yeah, here's the and they said object was a dict. Yep. Oh, and this is the whole thing that does if things failed in the lower level. Yeah, get action. So it's a pretty big example. So which is actually not a bad way to point out why it's a problem. So string, yeah. Case JSON value, if it's a string, which this is already a type, so expected a string got, expected an integer got. And then here's Json.Decoder. We're writing the type JSON value, result string something. Yeah, so same fundamental insight, but I kind of wanted to come at this myself to really understand what's going on. And he already had his help, collapse results. List of results, result of, yeah. Result of list. Field name decoder JSON. Punch a multi-field decoder. Object 2, which at the time this was written, that was actually a method. Or maybe he's saying, okay, object 2 turn comes map 2. Decisions while decoding. And that's and then. And this is not using like, yeah, this could use some sub decoders. All right. Pretty much the same conclusions. Well, that seems to be a bit of a complete run. So that is that for today. Okay. Thanks to Ocerat Gaming, Stormy Ice Leopard, Lizzie Live, Cat Knox, Haskin TV, Deadly Tacos, and Dog and Lake for hosting me. I'll get that off there for next time. This is approximately when I stream. So pretty standard wrap up today. Times are US Central, but hopefully you can extrapolate from the red line for your local time zone. I'll be back I expect to be back in the afternoon for gaming. I'll see what NeuroSlicers is up to. If there's no significant change, it might be time to let it go. They were actually saying that they kind of made their pre-alpha test too long. So I'll see what's going on there, but might do something else. That's it. Bye-bye.